Welcome to the 3.4 podcast on Newton's law of inertia. And Newton's first law here, let's change the pointer. Newton's first law states that every object continues in a state of rest or of uniform speed in a straight line unless acted upon by a non-zero net force. So Newton's law is often called the law of inertia, and you can see why very soon here. So let's look at his idea. His idea is that things tend to keep on doing what they're already doing, and that could also be could be in motion or just at rest. So an object at its state of rest would tend to remain at rest, and only a force is going to change that state from rest. Now, this is one of my favorite pictures, and up here is Newton, and he's standing on Galileo's shoulders, and this is when he summarizes his first law. An object at rest tends to stay at rest, an object in motion tends to continue in motion at constant speed in a straight line. But this is the part I really love. He said this: "If I have seen so far, it is because I have stood on the shoulders of giants." And of course what he means is that Galileo's shoulders. Newton's findings could not have been possible without Galileo first doing his work and producing his ideas, which of course he was persecuted for. So let's look at this. Here's objects that rest tend to remain at rest, and you can see that these items on the dinner table are remaining on the dinner table when the boy there pulls the tablecloth, and those objects on the dinner table have inertia. Here's another joke. So, anyways, let's talk about an object in motion. Now consider an object in motion. So in the absence of forces, objects tend to move in a straight line indefinitely. And I like to use a hockey analogy, because hockey player moving a puck across the ice, the puck really is going to lose too much speed. There's not much friction, and it tends to stay in a straight line. So let's say we toss an object from a space station located in the vacuum of outer space. In theory, the object will move forever due to its inertia. Now, when we talk about a vacuum, we don't talk about a vacuum cleaner. We mean that the vacuum of space is a place where there are no other atoms, and therefore there will be no friction. This is one of my this needs to be explained a little bit. This is a picture of a postage stamp talking about the Pioneer and Voyager missions that the United States, NASA, sent out in the 1970s to go look at some of the planets in our solar system. And at this point, they're very far out there. In fact, I think they just technically left the solar system in the past 12 months or so. Anyways, a movie I watched when I was younger was called Star Trek: The Motion Picture, and the idea behind it was that one of these spacecraft, specifically I think it was Voyager 6 or Voyager 7, went out of our solar system and kept on traveling because there was nothing to stop it. It had inertia, and eventually it was found by intelligent life somewhere else in the universe, and they decided to help it. So they made this gigantic, attached it to a gigantic space vehicle, and this is the original Voyager, and a Voyager, which they called Voyager. And you can see around here, this is just a small part of what the aliens added onto the Voyager. And the idea is that the Voyager and the Pioneers are still going, and they'll go forever until they either hit something or get pulled into the gravity of a planet or something like that. And that's all because of the inertia. There's nothing in space to slow them down. So, we've probably all played air hockey before, and on an air hockey table, if you slide a puck across an air hockey table, you'll notice that the puck will seemingly go on and on and on, whereas if you slide a puck across, say, a gym floor or a city street, eventually it will slow down. So talking more about Newton's law of inertia, we know that objects continue to move by themselves, and that forces are needed to overcome friction, otherwise they're going to slow down. And also you need a force to set objects in motion initially in order to start it in motion. And that once it's moving in a force-free environment, such as the vacuum of space, it will move in a straight line indefinitely at the same speed. And here's a boy sitting in a wagon being pulled by a dog, and if you look, he's sitting in the wagon and he is at rest, and then the dog sees a cat and suddenly pulls away and pulls the wagon out from underneath him. So he's at rest, he has inertia, and he tends to stay at rest, but the wagon's being pulled out from beneath him, just like the old tablecloth trick. And here's a truck, and the truck is going to hit the strong man, and because it has so much inertia and it's already in motion, if you see, once it hits the man, it tends to stay in motion. So a body in motion tends to stay in motion. Let's do a little think. Question here is if the gravity between the sun and its planets were suddenly disappeared, what kind of path would the planets move? And the answer is that the planets would move in a straight line at constant speed, because think about it, they're hurtling through the vacuum of space. There's nothing to stop them. So is it correct to say that the reason an object resists change and persists in its state of motion is that it has inertia? They don't know why the reason why objects persist in their motion when nothing happens, but the only thing they can do is call it that property, inertia. They don't know why, they just know that they do. So what is Newton's first law of motion? Newton's first law states that every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero net force.